Hello, everyone. It's almost 4 p.m. Central European time. Just to let you know that we're going to get started in 2 minutes, just to wait for someone else to join the webinar as well. Okay, just to check connection because I'm trying to share to turn on my camera, but it doesn't work for some reason. It's a bit pity. Can everybody hear me? Okay. Well, it's 4:01. I think we can already start, and then everybody else will simply join us and keep up with me. But please let me know, first of all, if you can hear me well. All right, Dietrich, thank you. We can hear you. Just got confirmation. Thank you. So just quickly switching to the presenter view. Yeah, once again, hello and welcome everybody to this webinar. My name is Roman. I'm head of engineering at SDC Verifier, and today I'm going to cover lifetime extension for heavy lifting and port equipment using also smart asset management platform. So here is the short agenda. We'll talk about why lifetime extension is critical challenge in the industry, also about typical barriers to safe lifetime extension. We will talk about how can we go from structured checks to asset level decisions. Yeah, also using smart asset management approach for lifetime extension. What does it give for the business? What is the business value for of this management? And we will have short Q&A session in the end. First of all, this session will be recorded, if I didn't say it before. So you will receive also recordings, and if you have any questions, please leave your questions in the chat, and I will ask them at the end of this presentation. A few words about ourselves for those who are just joining and don't know who we are yet. We are the Dutch company who was founded by Walter van den Bos. He's professor at Delft University, and we are based with the headquarter office in Haarlem, Netherlands. We also have two other offices in Krakow and Lviv. And maybe a little bit about the background, because we started quite many years ago from engineering consultancy services, from one-man company, and now we grew to many people. Basically, we were helping industries around to understand what is the condition of their structures, conducting design check and optimization services, and many other things. We were using FEA, but thing is, turned out that the range of services is pretty comprehensive. So basically, what we do now, we do a lifetime extension of structures. If you could guess from the topic of today's presentation, we use FEA approach to verify structures according to standards. We also do measurements and inspections, design solution optimization, retrofit and strengthening. This is all part of our daily routine. But then we noticed that many things using FEA software can be automated. So we started developing our products, basically like add-on for popular FEA packages like ANSYS, ThemeUp, and SimCenter 2D. Later, we noticed that there are many gaps in the software which can be closed, so we developed also all-in-one software solution, which is a standalone to SDC Verifier, and the fifth tool on top, which is SDC SAM, but I'm going to explain later on. So yeah, so it can be all gathered into a very short summary. We have over 40 team members. We completed over 350 projects. That's the value is a lot higher, of course, and we also have over 1,000 users benefiting from our software. What I'd like to start from mentioning that I just returned from TC Europe in Hamburg 2 weeks ago, which is, of course, another good chance to meet in person with our existing and future clients. Yeah, I just collected some really live pictures. I do like them. And we discussed latest advancements and industry solutions. But I also spoke with many crane OEMs, asset owners, maintenance managers, terminal representatives, and crane retrofit companies. And one more time discussed their challenges, but all of them, they shared a common concern. And that was a common ground, actually, how to extend service life of their structures, how to carry out structural retrofitting and modernization safely, and eventually, how can we optimize design from scratch to ensure safe and reliable service. Many of them either did not fully know the actual condition of their assets or only had very limited and fragmented information collected over the years. And my honest reflection is that the more I discuss this topic within the industry, the more I see the massive gap in reliable maintenance control across very different companies. And at the same time, I see the growing need to discuss this topic further and help those companies develop practical solutions. So we still have many cranes and other handling equipment that were designed and manufactured decades ago, right? So with this STS cranes, RMG, RTG, ASC, MHC cranes, overhead cranes, gantry, and all kinds of cranes. And many of them have already exceeded their design life, and others are just approaching it, as many industry representatives tend to say. So consequently, many of you are facing various issues, including structural problems like crack, you can see in the screen, corrosion. I'll try to use my pen. Yeah, so here you see the crack, including corrosion. Also there. Yeah, here is the massive crack, for example, in the Jeep crane. Here is the crack which was already repaired and reinforced. In some cases, this is really severe situations where you have significant loss of material, and yeah, this all leads to consequences in the end, to logical capital expenditures related questions. The question is, do we need to scrap the old crane and budget for a new one, invest in millions of euros just to keep the business running? Or can we just keep the existing cranes in operation and save considerable amount of money by extending their service life? Yeah, so these are two main problems that everybody's thinking about. But I would also like to highlight a third scenario, on the other hand, where the asset is still within its design life, but is already cracking or experiencing other types of structural damage. So the question then becomes why this happens and how to deal with it. So there may be still years left before the structure reaches its design life, yet it already has structural issues. So you can see some basic examples, for example, in this STS crane, yeah, some weak areas, typical areas at the gusset plate connections. So basically also new cranes are cracking. Or if it's something completely different, for example, you say, okay, but we have overhead cranes. It also might be the case. Very various issues. This is just the only example. And this is probably not surprising to many of you, because if you've been in the industry for some time, I'm sure you have already seen or faced this scenario yourself. However, this only shows that the scale of the problem goes even beyond the previous two cases, because train maintenance already becomes a serious pressure point requiring significant investment just to keep the machines running. Yeah, and this discussion about the CAPEX expenditure become a real and immediate concern. So let's spend a moment and think Why this happens? Because in the first two cases, the lifting equipment were designed many years ago, and this was often done according to old standards, for example, like DIN standard, NAN standard, or FEM standard, and more importantly, using simplified rules. Yeah, so design was often based on either accumulated experience or on hand calculations, or for example, the spreadsheets that neglected many details because the reality is somewhat different. Yeah, that lacks the complex behavior of the structures, all kinds of stress concentration points, and so on. At the same time, there were many conservative assumptions made about how the crane would operate. For example, in this picture, so we see the STS crane and the trolley running along the bridge and the boom. Yeah, so basically it's running from outreach to backreach and vice versa. And the problem in this case that the assumption is trolley is constantly traveling from outreach to backreach, which is of course not true. Second drawback is that the crane is constantly lifting the maximum capacity, which is also not true. Because if we look at the real crane working conditions, we can see that there is more gradual distribution, and we see less, for example, frequent movements at the tip of the boom as well as at the back reach. Well, it's more dense, let's say, between the water side and the land side legs, and that provides completely uneven distribution along the bridge, boom and the bridge, leading to the different level of damage. If we're talking about the RMG cranes or gantry cranes, the situation is basically the same because the frequency of usage of trolley along the for different lanes is varying. What's also more important, turns out that the average lifted load over the years may be only 75% of maximum rated capacity. Yeah, because in previous case I said, okay, we assume that it's 100% of the rated capacity. So that all makes an impact on your remaining lifetime. And in the end, the conclusion about design life was drawn for the complete structure. For example, we say, okay, it's designed for 25 years, point. But reality is a little bit different because in reality, service life of each structural member and local detail is different. So that is why you may see also a crane that should have been decommissioned years ago still running with only a limited number of visible issues. And the drawback, of course, in this case is that it remains a black box and your actions become reactive rather than proactive. Yeah, but there is also the third case, which we mentioned, and let's assume that there is not even the result of hand calculations or spreadsheets and that more advanced FEA calculations were carried out. Yeah, so even then, experience shows that the analysis is still very often simplified, relying on BIM models and past experience, for example, like you can see in this example. So here you see the fatigue damage for one of the STS cranes. If you go into detail and look, for example, at this front cross beam and you create a more detailed model, at least using the shell elements, and then you check again the fatigue damage, which allows you to take into account the correct weld directions, stress directions, classifications, and so on. Turns out that it's not within the limit, and you have various issues, often hidden inside the structure or in the hardly accessible areas. Yeah, and on top of that, when developing a new design, let's assume you're a designer or EM, everybody's interested in optimizing structure members, cross sections, plate thicknesses. This is all also to reduce structural weight, load on the wheels, and of course, cutting costs. Yeah, but at the same time, very often people are under the time pressure with limited capacity, and that drives simplification. So this also has consequences. And now imagine that you are the asset owner and you want to carry out structural retrofitting and modernization. For example, you want to increase the height of your crane. Yeah, in this example, for example, it's 11 meters. And you use the insert, for example, here on top, which is over here, just to point it out again. Yeah, or another example where you want to install an extra frame somewhere at the bottom, just above the seal beams. Or it can be something else, for example, the length of the boom. For example, increase load capacity of your crane, rail span increase, any structural changes to structural members. Even if you conduct SPMT transportation, which you do just once or a couple of times, or it's transportation on the ship from one location to another location. All of this have even more far-reaching consequences in the future. Another set of barriers to safe lifetime extension can be grouped into two main areas, which you can see over here. So this is basically basic set of critical, historical, and operational information. But if you want to break down this set into the list of questions, it can be translated into something like, all right, is your structure nearing already beyond the original design life? Do you have calculations available for this structure? How detailed are they? And very often they are completely missing. So there is an old crane, nothing is available, you just have drawings, that's it. Have you ever inspected your structure? Everybody says, okay, we did. Well, actually, not everybody, but very often, let's say, let's be honest. But how was it done? Well, was it visual inspection? Did you do NDT or general review? What was basis for all this? Do you have any calculation support in this? Because it's a huge structure, right? It's usually to overlook things. How frequently do you do this? How frequently is it planned? Do you have historical review of findings or any information structured and incorporated into your maintenance plan? Have you noticed cracks or visible damage? If so, what did you do? Did you just reweld those areas or did you come up with reinforcements? Have you ever made modifications or repairs compared, like I mentioned? If so, how are they implemented also? What are they based on? Did you just weld plate because it looks big or did you do reliable calculation supporting your decision? Has the structure experienced an accident in the past? For example, I don't know, running into something. Yeah? So that was an accident. And what was the impact? Did you do any calculations confirming that it's still safe to operate? Yeah, because okay, we got some plate deformed, but nothing else. Okay, but you can have something popping up in other spot which is hard visible. Have you ever installed any additional equipment? Yeah, sounds like a simple decision. Okay, I want to install E-house, M-house, or some platforms, or increase a little bit the weight. But what is the impact? Do you have any calculations confirming this? Has the lifting capacity been increased beyond the original specification? That's also important because everybody wants to, okay, I want to go higher by whatever, 10 tons, 20 tons, whatever it is. But what is the impact? Do you have any calculations concerning this? What is the remaining lifetime impact on it, basically? And last but not least, are you recording history of all this lifted and transported material? Do you store your cycles? Do you know how many of them did you already perform? What are the crane movements over time? What is the impact? So these, yeah, basically these are really, really endless list of things you can keep. And if you're still hesitating about whether you need structural verification of your asset, those who are presenting here, you can request and we can send you the full list of questions after the webinar to help you better understand it. But yeah, that's a typical thing that everybody neglects, but it all has consequences. So the question is, what is the right way to proceed and where should you start? And the most reliable approach so far is to begin with structurification of your assets, using FEA approach rather than hand calculations, which I would consider as a first step. In general, it can be done for any type of your crane. It can be done for gantry cranes, all kinds of basically 4-gear, 2-gear cranes, STS cranes, again, all kinds of ship unloaders, ship loaders, gantry cranes, RMG cranes, PEEP cranes, all kinds of also vessel-mounted cranes, stacker reclaimers, RTG cranes, straddle carriers, AAC, and all kinds of trolley solutions. And this is a pretty universal approach towards solution. Because idea is you create a detailed model, you do not neglect critical connections, you model them in detail, given a clear and accurate picture. For example, in this screen, you see, okay, all these connections which are translating forces from one member to another, they should be followed using detailed modeling approach. Yeah, including the fine mesh quality where required, of course. At the end of the day, that provides you accurate results, basically. So you can see you have a targeted overview, okay, about the weak areas for strength check, about the fatigue areas, about the buckling issues, and these things. And idea is that that allows you to see things that are normally invisible for regular inspections when somebody goes on site without any background supporting his plan. What's more important, this should be done according to industry standards, for example, like EN 13001 or Eurocode or other standards. Somebody's following also FEM 101, but it should be done according to rules. Second major step while doing this is operating conditions, which I already mentioned. They should be represented accurately, confirming your real operating scenarios. I mean, making far too conservative assumptions that the trolley is running from one position to another without any without any frequency difference, especially for the STS crane, might be really misleading into all this in all this story. Yeah, for in some cases you can do that where the data is completely missing and you are simply unable to rely on nothing because yeah, this is safety first. But if you want to work towards lifetime extension, please do store these things and yeah, gather as much as possible information about it. Something else about the classification, because using this advanced approach, you can take into account, okay, what is the weld type, what is the weld quality, which depends on various technical things like weld direction and things like that. I'm not going to stop in detail, but I think you're very, very aware of that because it's a notch class, FOB class, or characteristic fitting scheme for welded joints. And eventually, all this leads to the detailed overview of all fatigue-prone areas. So this makes targeted inspection possible instead of inspecting the entire steel structure where it's easy to overlook issues hidden under paint or localized in small areas, like in pictures I presented a few minutes ago. On top, it also takes a huge amount of time to inspect the whole structure. So when inspectors tell me that, yeah, they just do inspection, it always makes me wonder how this can be done reliably and how long it will take actually, and also how properly would it be done. So what happens in this case? You're no longer living in a black box, reacting to problems and making repairs without knowing where the next issue may appear. Instead, you act proactively with a clear inspection plan, knowing that if these several critical spots, for example, those highlights in this STS crane, are checked and found to be acceptable, then the rest of the structure is also most likely acceptable. Yeah, so you are following a targeted, clear navigation plan. And yeah, so basically we have the first step, the structure verification according to standards. And I'd like to emphasize that, yeah, it is extremely valuable approach indeed, but it should be always followed by visual inspection as step 2 of actual asset, because it is essential to validate the physical condition of the real structure against the numerical model. Because we're using it as a tool, but it's still a tool, right? You want to validate things and to make sure, okay, what is the actual condition? For example, corrosion may make things worse, right? And normally you find it out through inspection. There may be also unusual situations like, okay, I have FEA results showing the problem, but it has not yet appeared in reality because the crane has operated under more favorable conditions. Or vice versa, the results do not show the problem, but you go on site and you see that the issue exists in the crane due to some exceptional scenarios. Real like one example from one of our projects, I like to say, when yeah, we got results, everything was fine, and then we go on site and we see a crack. We cannot figure out, okay, why this happened. Then we started figuring out and talking to also crane operator, and turned out that the crane operator was all the time running into the buffer because it's faster to stop the crane. See, so it's really essential to gather as much information as possible to have it complete. Yeah, and these are just 2 steps. You got results, you got them inspected, so you gather two packs of results. But of course, there is also step 3, and yeah, this data should be then consolidated and structured into a predictable maintenance plan for the future. So, what is the structure condition? What was found? A clear overview with pictures. When it was found. which actions were taken, by whom, when is the next inspection is due, what must be inspected, and so on, and all in order to reduce downtime and avoid premature end of life. Yeah, so it's still an open question. How are you going to do that? And this is all about our structural asset management platform. So who can benefit from this platform? Basically, all kinds of representatives, starting from asset and plant owners, OEMs, manufacturers, maintenance managers, maintenance companies, port and terminal operators, inspection and repair providers, all kinds of parties. So what is the idea? You log in into the tool, and after the login, you can basically log in using having a different role. So, for example, if you are an inspector and you only require a limited number of information, you have a different permission. If you're an asset owner and you do not want to share this amount of information with some people, you have a different role as well. Also, third party or repair companies, they can get into a different information through this. Once you log in, you see the main window with the assets. So it can be anything. So what do we call with the asset? It can be all kinds of types of structures. So starting from front loader or gantry crane or STS crane, straddle carriers. If you say, okay, I have ship unloaders, but I have like 5 of them, while I have 50 STS crane, that's fine because you can group them and you can access them also as a bunch of assets. So what you can see here, you have type of asset, you have description, which you can put it yourself. You see the department and you see the address of this asset. And then what happens next? You can see them also on the map. For example, you have a very limited number here in the map because if you have assets located in different areas, which is most likely the case. So it's basically a Google Maps functionality, so you can zoom in and zoom out, and then you see where is it. You can also link address directly by clicking on the map. And what's more important, you can add new asset. Yeah, so you can set a name, put a description. You can also create a new type, department, link it, like I said, and do all the things yourself. Yeah, you create you select the type from just the drop down list from what is already created. So this is just common structures, but if you need another one, that's not a big deal. And yeah, the department, who do you belong to? For example, engineering department, or is it a steel plant or maintenance group, or maybe some inspectors? Again, this is all customizable. What you do next, once you access to the details, so you can access to the main information through the map or just by clicking here on the details, and then it gets you to the main window of your asset. So few points to clarify. What you can see just in front of you is, okay, general information. So the type of your asset, the address, you can see the location. So basically where it's located, right? You see the days until next inspection. Yeah, so you see last inspected, and then you see, okay, I have 59 days left till next inspection. You also see general health status of your assets. Yeah, so you see that overall there is a good status, but there are points to be clarified. Yeah, so they are divided into different categories and level of criticality. So fair, poor, and critical. So you see that you do have critical or poor or fair health statuses for some of them. What else? This is also divided over components. So how many days left, for example, to inspect each component. Basic information like, okay, what is the real pictures, general arrangement drawings, or the FEM model. This is also accessible from this main window. What is then? Then you're switching to the next step, which is the components. Because what is the idea? Your asset consists of many structural components. Yeah, so it can be pylon heads, backstay, bridge, boom, and so on and so on. So eventually the health statuses of each of these components is defining the health status of your asset as such. So you see here a clear summary over the different components. Yeah. So what is the maximum calculated fatigue damage value? What is its current status? Last action date, for example, days to next inspection. You see also tickets, but it's something I'll explain later. So for example, in short, how many areas do you need to check per component? Yeah, and this area is just a characteristic from the calculation. Yeah, and you have a navigation pane for each structural element. Yeah, so if I go here, okay, I see that my waterside seal beam over there, I see that it's divided into parts. Because if you've seen a crane in reality, you know that, okay, length of the boom is significant, right? The length of seal beam is also significant. So that's a huge structural component, and we have to dive into more detail somehow. Yeah, so then it's divided into parts and then panels and plates. So basically you have a complete breakdown until you find a spot which you need. Let's, for example, take a look at the waterside seal beam. Yeah. By the way, there is a very nice here dynamic button. So once you just target your cursor over here, it shows you what is it specifically. And so if you're not familiar with names, not a big deal, because once you put your mouse there, it shows you directly in a 3D model online what is the structural component meant. Yeah, so we see that for now, go in here. This is the waterside seal beam. We see that the general health status of this beam is quite okay, but we have 5 critical spots to check. Yeah, 4 tickets overall to inspect because we have one part 1, which has unacceptable fatigue damage value. So it's currently one of the part in this seal beam is having a poor health status. So what is this part? You see the number of areas over here. So you see number of parts, and these parts are also highlighted with the numbers here on the side. And each part is then also highlighted with the representative picture. So this is all in order not to get lost. Consequently, all results from FEA analysis which you received earlier, they are automatically linked to the appropriate part of your asset, right? So like in this case with the seal beam. So if we take a look deeper at this part 1 of the seal beam, we see, okay, this is one of the ends of the seal beam. And we see specifically, okay, we have a hotspot area right at the bottom. Yeah, so in short, for those who are not really familiar how to read all this, orange and red, it's not okay. Everything else is fine. Blue is the best. So the lighter the color is, the worse results are. Yeah, so what you see here, a full breakdown. I know it's somewhere here in this part, and I want to go further, and I want to know, okay, what is the plate specifically having this issue? I see that this is the panel number 8, and there is one plate. So I see then in-depth information specifically for this plate. Then yeah, basically including the points of interest. And then you have it for every single structural component. This breakdown it's also summarized as the list of tickets. So basically, this ticket that is something that you have on board to check further during your inspection. For example, you calculated your model. You see, okay, I got 100 different yeah overstressed areas. They might be really very often located within, I don't know, 5-meter area. So it doesn't mean that there are 100 different spots randomly located in the crane and you have to climb all the way around using, yeah, spending ages. But that gives you a clear navigation how not to miss a hotspot. So basically, you have a full list of things to be inspected, yeah, with a certain status that is assigned also automatically, and then you can further organize this in the jobs. For example, you say, all right, I have an inspector who's going to visit the crane and he's going to check all these areas. So you assign directly a task to him. You see the action status. It's overdue because it should have been done earlier. And then you have action date, you have due date, you have ticket information, you have any details. So full list basically then transformed into a clear planning. If you click at the ticket or the details, you get into more detailed information. For example, when I go on site and I see, okay, it used to be, yeah, so this is the current action information. We see that there is a poor health status. Yeah, we know that due date until we have to do that. We know the action date. You go there and then you see, okay, we found the paint damage. We found localized corrosion. We found also general corrosion. We also found some initial fatigue and the crack of over 15 centimeters. So what you do next, you assign a new action. Basically, you say, okay, there must be visual inspection or repair or whatever, and then you also have a due date and the health status after this inspection. Yeah, so you also select who's going to do that. For example, this time it was done by one guy, but next time it's going to be done by somebody else. And if you see that this information is fairly limited and you would like to add some more information, like, okay, there is pitting corrosion, or maybe there was a buckled plate and you want to indicate that, or some wear, or a strength crack, or any other issue, basically you can add this directly by customizing this field. After you update the ticket, you get the updated information. Yeah, so you see that, okay, we have to conduct repair, so the status is critical, and yeah, the workload, like I said before, is planned into jobs and assigned to very specific people. The pictures which you take during inspection, they directly appear spot by spot. So each time you get there, you see a picture and the result of your inspection. When you go to ticket details, you see the full information about this. For example, okay, according to FEA results, the utilization factor was this or this. So you see average, minimum, and the maximum. You see the picture of the real crack, which was detected at the location, and then you see the action history per every single point. So it's then structured automatically by point, right? So you see that, okay, there was FEA analysis, automatically it was assigned a critical status, and then you have visual inspection, it's pending. Once you change the status, it turns into something else. So the action status will be conducted, and then you assign the next action date. You can also adjust it, like I said, by modifying basically this basic information if you need that. And if you need to add more properties, very custom ones, this is also doable. Yeah, so you just click in on add property, add this definition, you put a name, you put the description, which you think, okay, also the way you're going to see this, so whether it's a string or yeah, the list, and the units you want to see. What can it be? Well, for example, where, but very specific related to your question. Or for example, you have something strange happening to your structure and you would like to identify it as a separate property. The next step is the resources. Yeah, so we were here, which are the actions where you are going on site and you're assigning you're determining the health status of your asset. But this tab is resources. It's related to basically centralizing all information within the platform, because you can upload all kinds of reports, for example, directly here, which is related to your crane. All kinds of documentation. If you have FEA model, you can also upload it here. Drawings, they're also stored here. All kinds of link to any also system or PLM information that's all can be synchronized together as well. One important announcement is that I think everybody is facing the issue. You go on site, you take like hundreds of different pictures, and then you have to figure out what is what. You need to sort them, you need to make a report, you need to make something clear, and then in 5 years, you forget everything. But also very often, you go on site and yeah, you want to take a picture and you want to upload it in the platform like this, but there is no internet connection. So we started developing also mobile application. So idea is that this is also working offline. So you go on site, you take a picture, and this picture is automatically uploaded to the correct area of your asset. And you can access this information anytime from any device. We have already workable version, the prototype version, which is already developed. Basically, you can see the real screenshots of this application in the pictures. All kinds of statistics, summary, attachments. This is all can be really handled there in a very convenient way. So that's all even more simplifying your life. And yeah, figuring out, spending hours or days what was done and what it belongs to is no more an issue. So in general, reliable lifetime extension and proactive asset management, it can be achieved through the following 3 steps. Step 1 is, of course, structural verification according to standards. So this can be done either by using our all-in-one software solution, provided that you have the required level of expertise, or by using our engineering consulting services, where the entire scope is carried out by our experts. Yeah, but this step is essential. You can do it yourself, or we can help you to do that for you. Step number 2 is conducting targeted on-site inspection based on FAA results, which again is a huge time saver, as it allows you to focus directly on critical areas instead of spending ages trying to identify where problems might occur. And step 3 is, of course, accessing our structural asset management platform. So these all 3 steps, they're synchronized together, because here in this asset management platform, all asset-related data, including FAA results, re-inspection findings, is centralized. So that provides you with the complete transparency and visibility, and you can take control over to proactively address potential issues, optimize costs, and improve safety. So if we want to outline it into the clear business values, what does it give you? First thing is, of course, it provides you with reliable lifetime extension, yeah, controlling risks and costs. Second thing, you have clear proactive plan rather than reactive decisions, leading unforeseen expenses. Third thing, it reduces unplanned downtime and inspection delays. Just a use case example. You have a serious problem appearing in the crane is shut down, then the time is spent developing solution and implementing it. Then the crane is put back into operation, and then the same situation occurs again unexpectedly, each time increasing downtime. So instead, you address it properly once and continue operating safely, allocating time only for periodic inspection planned in advance. But you are not living in a black box that, yeah, each time expecting something you don't know what, and leading to this downtime and costs. Fourth thing, you have automated solution supporting also mobile application, which is going to be released soon. Automatic documentation, which of course is based on compliance with applicable standards, such as the ENTER 2001. So it's supported by full confirmation and complete documentation for checks, review, submission, whatever. And also idea is that in this asset management platform, we have on list ongoing improvement so that you can directly not only accessing the report from FEA model, which our software provides anyway, but directly generating statistical information and the health status information, so that you can just send a bunch of papers to the people needing it. And last but not least, this is a synchronized workflow, so it works both directions. And yeah, if you started using an asset and then in 10 years you have more number of cycles performed by the crane, of course you want to have it updated. So that is something that is synchronized with the platform as well. I was trying to be to fit within the time range of this webinar, because having just 1 hour is really a limited amount of time to present all kinds of things, because of course there is more things to discuss. But I'm also hoping that you have some questions I can answer, and yeah, it will provide you with even more value. All right, I'm now in a chat, and I see the question from Jane, from Aman Jane. Global circular economics matter. Sure, that's fully agree. And we have question or rather a comment. Additional strain is to be ensured at critical joints and location. That's correct. I think that's something I mentioned as well. Present crane operator expertise need more precision training while lifting or placing the loads. I think this is also a good comment. And frankly, just trying to reflect on these TOC takeaways, because industry is also slightly, slowly but confidently shifting towards the remote operation. So I would say that expertise for crane operators will only be even a more of an issue, because if you are a crane operator running a crane, you can also feel dynamics. But if you're using a remote control, these dynamics are quite overlooked and missed. Although I saw quite some companies, they are developing nice simulators, and they are saying that yeah, this is very close to reality. But I think that still remains an open question for the future, because even with the real crane operators running the crane on crane, that creates problems. But on a remote operation, that's probably going to be another challenge for the industry. Um, Digital cranes can improve the understanding and the application of the hydraulic system. That's true. I think it's yeah, it's related to everything basically. FEA is indispensable to ensure longevity. Yeah, I see quite some list of not even questions, but comments or statements which I agree with, and I think I mentioned it. Cohesive strength between the atoms can be increased using. Okay, that's a interesting point also. A Fifi do 3D scan is essential for FEA analysis. Well, that's a good question, but it depends actually, because um, 3D scan is useful, but there are pros and cons, let's say. Or pros is that you can capture in pretty much detail the global dimensions of your crane, the height of the shapes, and so on and so on. But um, what is inside the crane, so the plate thicknesses, the diaphragms, this is something missing. So preferably, it's really preferable to have the drawings, the welding drawings, and or some maybe 3D model, but that is not based on the 3D scan. However, there are cases when this information either very limited or completely missing. For example, yeah, that's an old crane and all documentation got lost, and yeah, you need to do something. So of course, the 3D scan is very helpful in this case, because yeah, you have the point cloud, which you can further convert into the CAP model, which is much better than just guesses and measurements from some PDF. Yeah, I hope I answered your question. So it's useful, but not always really needed. For database recorded by phone can be synced later in SDC asset app online. Yes, that's the idea. So I did mention that it works offline, but it also, of course, works online. So if you take some pictures, for example, offline, being somewhere inside the crane, once you get to the internet connection, then it's automatically synchronized, and then all the platform and accounts, they receive this information. Yeah, so it's a temporarily, yeah, there is a temporary delay while not having connection to the internet. Okay. Um, I got another question. Hello, can we have the presentation video after it ends? Yes, of course. I think I mentioned at the very beginning that the webinar session is recorded and it will be shared with everybody. Next question, is the integration of SDC Verifier results into SDC SAM automatic? For that moment of time, that requires limited amount of efforts by engineer to do that, just to translate. But I would say that the major part of information is then automated, and the plan for the common future is, of course, make it fully automated. We already have a button inside our tool, which is getting data at SAM or transfer data to SDC SAM. So it is already compatible. It's not like you are sitting and all the time manually transferring this data, but of course there are some limited number of actions still required. Okay, I got another question. Could you briefly explain how is the workflow to perform the structural verification? I guess it starts with the global model using 1D element. Is the detailed analysis done using another commercial software like ANSYS? I think at this point I can go somewhere where I was at one of our slides. I did not want to focus too much on details because otherwise this 1 hour would become a lot more. So there are a few typical methods how to do that. Yeah, there is a common practice, let's say, but experience shows that the common practice is not always the true approach or correct approach, because if you start from 1D element, that is fine, but it's important to ensure that this 1D beam element approach does not remain the only one in this verification. For example, if you started with beams and then you see, okay, here I have completely fine stress level, yeah, here also, but here I have somewhat higher, also here are maybe completely unacceptable. That's an indication that you have to go into more details. This is inevitable, because if you miss this step, it's dangerously misleading point. It's easy to overlook fatigue-prone areas. Yeah, so 1D beam element approach is very good, for example, if you want to quickly understand what's behavior, if you want to quickly receive, okay, what are the corner loads of your crane, what are the wheel loads, what is the COG and nature of frequency, these kind of things. But for the reliable fatigue verification, 1D element approach is not enough, and it should be followed by 2D at least if you're interested in that, because 1D element has only one stress direction, while in fatigue, it's important to translate it into along the well direction, perpendicular and shear. So that's a very important thing. Regarding the next part of your question, is the detailed analysis done using another commercial software like ANSYS? At the very beginning, I was maybe a bit too fast on this, but you can use ANSYS, you can use FEMAP, you can use SimCenter 3D with the help of our add-on, because we are official solution development partner of ANSYS and Siemens, and basically our software works on top of their general packages. So this is one thing. Everything I explained is possible there directly. So if you are a ANSYS user and you want to do all this, you just need our add-on application for ANSYS. If you do not have neither of this software, we have all-in-one software solution, which is a standalone tool where you can access all kinds of features you see in ANSYS and FEMAP and other packages. So there is a modeling environment, calculations, standard verification, automatic reporting, and so on. I hope I answered your question. Then we have another question from Hafifi Hassan. If the crane have involved in an accident and affected the structure like buckling or deformation, do it affected the results in FEA? Does it affect results in FEA? I think you meant something else or wanted to ask, because results in FEA, this is the outcome of simulation. Yeah, so it's based on certain inputs. So if your crane was involved in accident, you have to do simulation of this accident, or you need to provide proper inputs. Of course, yes. But for example, if there was an accident and you have a couple of plates buckled, yes, of course, using our software you can simulate that. We had like many projects, let's say, having this, because it's not only the buckling issue, but this is also the local permanent deformation leading to reduction of the lifetime. And yeah, it may even lead to uneven or different distribution of forces between the members further. So that's something important indeed, and it can be done with the software as well. Bram, 3D scan. There was a comment I see. 3D scan is good for dimensions and deformations. Ultrasonic thickness measurements are critical for documentation of corrosion. That's a good point, Bram. That's true. And I think I did mention this on one of the slides, because if you go on site and you see the corrosion impact, yeah, that becomes essential point. You have to do the plate thickness measurements, because it's very often the case when you have a severe corrosion in your structure that leads to the lifetime reduction. Yeah, and if this corrosion is one of the pictures I showed you, like you can completely see through the plate, it's just the holes. Yeah, there is immediate repair required. Okay, Mort Juhairi. Sorry if I pronounce the name incorrectly. Just apologize for that. Does it mean you will do the elements for the whole crane, or do you only model the joints? The practical advice from my side would be, where is it? Just trying to get back to this slide. Practical advice from my side would be that it depends on your crane. For example, if it's STS crane, yeah, in most of the cases, it is enough to model the joints, but it shouldn't be very limited, let's say, detailed connection. So you keep it too close to the stress influencing areas and then provide in transition. But if you keep it far enough from these connections, so just to provide the accurate stiffness, in most cases that is okay. But if you have, for example, overhead crane, which is one of these, here it's much harder. So here you cannot use beam approach at all, I would say, because there are so many stress concentration areas and there are so many fatigue prone areas, as experience shows, that using beam elements for this type of cranes is dangerously misleading. So short answer, it depends on the crane. For some you can, but for some you really need full detailed modeling, like for overhead cranes, for example. Fifi, crystal clear, and thank you for the explanation. Welcome. Aman, special epoxies can provide effective. Well, Aman is just having fun with probably nice statements. Agree with you, Aman. Aman. All right. I quickly went through all the questions, I think. Is there more? Okay, Daniel. For other FEA software output, like do the conversion to SDC format, example SAM or Genie. That's a little problem because I suppose you're talking about the SDC SAM, or are you talking about the conversion from SAM or Genie to SDC standalone software? Because there are two components. Long story short, SAM, Genie, and these local applications, if they are, as long as this is compatible with ANSYS or FEMAP, which, as far as I know, not really, this is hardly to make compatible with the general FEA software. However, if we're talking about the asset management platform, we're now working on the solution so that regardless of the let's say, a package of information you have, you can still benefit from the tool. Yeah, so if you have, for example, if you never conducted FEA, but you have certain historical overview of your asset and you want to benefit from SDC SAM, scheduling inspection and keeping all this information, we have already worked around how to make it possible. But if you have a unique situation, we are ready to discuss it and make it compatible for you. Because yeah, the main idea is that we are open to any feedback, and this is not something that, okay, this tool is going to exist in only view like this, because we already received a request that, for example, companies have already existing systems, maintenance system, which they want to keep using, but at the same time, they still see a lot of advantage of using our tool. So we're open to make it compatible as well. Okay, Mort, last question. Is SDC SAM need to be updated manually, or it is linked to the FEA, and would it possible to include the load spectrum in the software? Load spectrum is the input for the fatigue analysis. Yeah, and SDC SAM is updated, I would say, in hybrid approach. I think this question was already asked. So the major part is already automated. It's linked directly there. However, it still requires the engineering effort to to complete the setup. So we are working towards complete automation, but for now there is a human being involved and still needed. And I believe you can do it yourself if you start using our tool. That's not hard to do. Conversion SAM Genie to SDC format. Yeah, I think I already answered that question, Daniel. If no, please let me know. Okay, good. Quite some list of questions, I would say. I spent almost 15 minutes or 10 minutes answering them. Anyways, if you have more questions, do not hesitate to ask. You can contact me directly using my email, or you can write to support@sdcverifier.com. And once again, thank you for being here, taking part in this, and it was a pleasure for me to present it. Thank you. And at this point, I believe we can wrap up and have a nice day ahead. Thank you. Bye bye.